I'm going to cover implicit differentiation. First, let's distinguish between functions that are written in implicit form and explicit form. Up to now, the form of function we have used as in explicit form. For example, if I want to find out, let's say, y is equal 3x squared minus 2x and plus 1. This is explicit form. Why we call explicit? Because it has only one variable. But at the second, I plug here y is equal, let's say, let me put this way, 5 is equal x cubed plus x squared, and then plus 4y cubed minus 2y. This is going to be implicit form of function. Why is it implicit? Because we can't just differentiate based on only x or based on y. We have more than one, and x and y. Okay? This is what we call implicit form of function. Now, if I write down x, y is equal 1, this is going to be implicit form. But the same equation I can write down in the form of 1 over x. Or I can write down in the form x is to power a negative 1. So this will be explicit. And this is implicit form. All right? Okay. Now let's learn, start with basic examples, how to differentiate with respect to x. Okay. So we start with basic stuff. Let's say we need to take derivative d by dx. We need to differentiate by x, and we have here x cubed, right? It's going to be 3x squared, right? Based on formula, that derivative d of dx from x to power n is equal n times x to power n minus 1. Yes? Okay. Next example. Now, taking derivative by x from y cubed. So, look what's happening. Here we have taking derivative by x, but it's given y. So variables here don't match. They disagree, these variables. Therefore, we are going to treat as a chain rule, free y to power 2, and take derivative of y, dy by dx. Okay, now what is y gonna be? Nobody knows. If it's y is equal, let's say, x squared plus 1, then easily we can differentiate because it's gonna be d by dx, x squared plus 1, right? But if it starts including more complicated things, but we don't know. We just put in general form dy by dx. Based on whatever y is, we'll take derivative. Okay, next one. Next example. See? So, derivative by x, and we have x plus 3y. So this is implicit form, right? So it's going to be d by dx of x and then plus d by dx from free y. Okay, so what does that mean? It's going to be equal derivative of x by base x. It's going to be 1, right? And here we have yet again, x and y. So therefore, it's going to be derivative of free y as a kind of chain rule, similar to chain rule, rather saying, plus free, and then we have to get the dy by dx, because we don't know what dy is, and it has nothing to do with x. So we need to take derivative. Okay. Next, example D. D by dx, derivative by x, and we have xy squared. Okay. While here we were applying addition rule, in this case we are going to apply my rule of multiplication. Let me remind you rule of multiplication. If we have x y prime derivative, it's going to be equal x prime y plus y prime x. Yes? Okay. So, well, let's do it. It's going to be, oops. So, x times the derivative of y squared, and then plus y squared derivative of x, right? Let me put here this x. And the result is going to be, so on this term, the derivative of x, x is out of derivative. So it's going to be x, derivative by of y squared based on dx, it's going to be times 2, and then y stays under derivative, dy by dx. Yes? Plus y squared is out of derivative, and d by dx for x, it's going to be only 1. Right? So the result is 2x dy by dx and plus y squared. 2x y. Did I forget here y? Yeah, because I have y squared here. Yeah, 2y, so I have to have here y also. Let me squeeze in. So it's going to be 2y as a chain rule, and then dy by dx. Okay, 2xy dy by dx plus y squared. Now let's do a implicit differentiation over equation. So we have y cubed plus y squared minus 5y minus x squared equal negative 4. And we need to find dy by dx. Okay? So we are going to differentiate both sides of the equation with respect to x. So since we have addition subtraction, I'm going to apply the property of addition subtraction, which is going to be d by dx of y cubed plus d by dx. Let me move this unnecessary space not to occupy. Okay. By dx of y squared minus d by dx of 5y minus d by dx of x squared, and this is equal d by dx of negative 4. All right, so if I take take implicit derivative from y cubed, the first term, it's going to be 3y squared, because remember, pay attention, we differentiate with respect to x, but here we have y. So I'm going to apply like a chain rule, 3y squared, and then get inside and differentiate y also, dy by dx. Next, chain rule, it's going to be 2y, and then getting inside of y and trying to differentiate y. Next, 5 is a constant. There is nothing, there is no elements for chain rule, and it's going to be dy by dx. And since here it's where it's going to be explicit differentiation, we have x and we're differentiating x, so it's going to be minus 2x, and derivative of constant is equal 0. Okay, so from here what do? We collect, you see we have a common factor here, dy by dx, dy by dx, dy by dx, and 2x I will move on this side. So dy by dx, in parentheses I will have 3y squared plus 2y minus y is equal to x. Okay, and from here I'm going to divide by 3y squared plus 2y minus 5. Here also 3y squared plus 2y minus 5. See here between them, between the dy by dx and the whole this polynomial expression, we have multiplication. So this polynomial expression is going to be as a coefficient for dy by dx. Therefore, I can divide. So this is going to be gone, cancel, and we get dy. Let me clean this. Okay, so dy by dx is equal to x over 3y squared plus 2y minus 5. Okay. Okay. I have mentioned a couple of times in my previous videos that taking a derivative, first derivative, it's identifying the slope, okay, and slope, and that is also we identify velocity. So let's find the slope using the slope of the equation implicitly represented by x and y. I want to show here the benefit of implicit differentiation, okay? So we have x squared plus 4y squared, and that is equal 4. So we need to determine the slope of the tangent line to the graph of x squared plus 4y squared equal 4 at the point square root 2 and negative 1 over square root 2. Okay, the graph of this function is, let me draw. Okay. It's not in the center. We'll move it to the center. Yeah, that's better. So let's assume we have here point, and this point is square root 2 and negative 1 over square root 2. Okay, and this is the graph of x squared plus 4y squared is equal 4. All right, so we need to find the slope at this point. Let me see. We need to find the slope of the tangent line to this graph at this point, square root 2 and negative 1 over square root 2. Here we can do implicitly and explicitly. Why? Explicitly, I can solve y from here. Let's say, I'm writing here somewhere, 4y squared, it's going to be equal negative x squared plus 4, right? Y squared is going to be 1/4 of negative x squared plus 4, correct? And y is going to be equal square root of 1/4. It's going to be 1/2. Now, since our point is located here, I'm taking negative part, because it can be plus minus, right? We're taking negative part because our point is there. And negative x squared plus 4, right? I represent it in the format of explicit function. Now take this, the derivative of this one, and let's see how far you can go with this. Now, and instead I'm going to take implicitly I'm taking derivative of x squared plus 4y. 4y squared equal 4. So if I take derivative in respect to x, then x squared derivative, it's going to be 2x, right? And for 4y squared, it's going to be 4 is a constant, stays there. Y squared derivative, it's going to be 2 times y, and then derivative of y itself, right? Okay, and derivative of 4, it's going to be 0, correct? So we have 2x plus 8y dy by dx is equal 0. So from here, 8y dy by dx is equal negative 2x, and the dy by dx, it's going to be equal negative 2x over 8y, which is going to be, okay, well, I'll do over here. This is going to be 1, this is going to be 4. So which means it's going to be negative x over 4y. All right. So we need now find the slope of the tangent in this point, at this point right here. So since we have derivative, x over 4y, so I'm going to plug dy by dx let me move this coordinate down here. Yeah, okay. And it's gonna be, so negative x is square root 2, right? This is x, this is y, correct? Square root 2, and y is gonna be 4 times negative 1 over square root 2. Well, let's do, since I have negative, negative, it's going to be positive, and 4 times 1 over square root 2 is equal 4 over square root 2, yes? Now, when I divide square root 2, divide by 4 over square root 2, that is equal square root 2. We flip the second fraction. I'm getting times square root 2 over 4, which is equal, square root 2 is 2/4 dy by dx. And it's going to be 1/2. While if you do explicit way, it's going to be rational fractions, exponent, and so on, and it won't be so easy to plug the value of x and y. Okay? So here we can see the advantage of implicit derivative. Okay. Let's find the slope of a graph implicitly. So what is our next function? Actually, this is not even function, it's a graph. And this is also not function, it's a graph. Why it's not a function? Remember? From algebra, because if you provide vertical test line, it's crossing the test line, crossing in more than 1 point. That's why it's not a function. Yes? And the graph of this function, we are going to take implicit derivative, is going to be, it looks like this. Okay, wish me good luck if I can draw it nicely. Let me take this one. No, this part is not nice. It's not symmetric. Well, hold on, let me one more time trying. Yeah, approximately. Everybody use your imagination. Okay. So, and what do we have? The graph, the equation of this graph is 3 times x squared plus y squared to power 2 is equal 100xy. So here there is no way we can represent in explicit form, right? And we need to find the slope of the graph, slope of the tangent line at the point 3 and 1. So assuming this is 3 and 1. Yes? And the tangent line is going like that. All right, so let's figure it out. So we are going to take derivative implicitly. So it is gonna be d by dx 3 times x squared. This 3, let me put closer. Three times x squared plus y squared to power 2, and it's equal d by dx of 100xy. So first we have to take derivative of this outside exponent 2, right? Which is going to be 3 times, this 3 is a constant, comes out, right? 3 times 2 x squared plus y squared, right? The whole this piece. Here it is. Now I have to now get inside and take derivative of x squared and then y squared. So derivative of x squared is going to be 2x, right? It's going to be 2x, and then plus derivative of 2y, it's using chain rule, it's going to be 2y, and then derivative y by x. Yes? And now on the right side of equation, 100 is a constant, comes out. And derivative of xy, it's going to be x prime. Derivative of x, it's going to be, let me write down, okay, in details. 1 second. Okay, it's going to be x derivative of y by dx, right? We're applying rule of multiplication, and then plus y times derivative of x by dx, which is going to be 1, right? So from here, our goal is going to be to find dy by dx, right? Because we take an implicit derivative, which means I have to open parentheses and I'm going to collect in one place dy by dx, dy by dx, dy by dx. Yes? Okay. So therefore, what is going to happen here? I'm going to open this parenthesis here. It's going to be 6 times x squared plus y squared, 2x plus 2y by dy by dx is equal 100x dy by dx plus 100 y, and dx by dx is 1, right? It's right here. So it's going to be plus 100 y. Okay. Now, what am I doing here? I'm going to multiply this 6. I'm going to multiply by this parenthesis. Okay, not by this one. No, by this one. Why by second parenthesis? Because I need divide by 2y dy by dx, and This dy by dx I need to release from there. So it's going to be x squared plus y squared, and here I have 12x plus 12y dy by dx minus, I'm bringing this one, let me clean here, minus, I'm moving this dy by dx on this side, collecting on one side, minus 100x dy by dx, here is equal 100y. Okay? So from here, our goal is going to be to find dy by dx, right? Because we take an implicit derivative, which means I have to open parentheses and I'm going to collect in one place dy by dx, dy by dx, dy by dx. Yes? Okay. So therefore, what is going to happen here? I'm going to open this parenthesis here. It's going to be 6 times x squared plus y squared, 2x plus 2y by dy by dx is equal 100x dy by dx plus 100y, and dx by dx is 1, right? It's right here. So it's going to be plus 100y. Okay. Now, what am I doing here? I'm going to multiply this 6. I'm going to multiply by this parenthesis. Okay? Not by this one. No. By this one. Why by second parenthesis? Because I need dy by 2y dy by dx, and this dy by dx I need to release from there. So it's going to be x squared plus y squared, and here I have 12x plus 12y dy by dx minus, I'm bringing this one, let me clean here, minus, I'm moving this dy by dx on this side, collecting on one side, minus 100x dy by dx, here is equal 100y. Okay? So now I'm going to take this entire parenthesis, distribute by this one and this one. How I'm going to do it? It's going to be 12x times x squared plus y squared, and then plus 12y times y squared plus x squared plus y squared dy by dx. Let me move over a little bit. And minus 100x dy by dx equal 100y. Okay? Without opening parentheses of x squared plus y squared, what I did, I just 12x multiplied by entire this parenthesis, and then 12y dy by dx multiplied by entire parenthesis. That's what I did. Okay, like terms, I mean not like terms, common factor, this and this, right? Which means this 12x, this one, I am moving over. Okay, let's work on it. So 12y x squared plus y squared minus 100x, and dy by dx comes out equal 100y minus this 12x x squared plus y squared. Okay, and from here, since I need dy by dx, what am I going to do? Obviously divide by this entire parenthesis, the square brackets. 12y x squared plus y squared minus 100x, same thing here, 12y x squared plus y squared minus 100x. Okay, so that is going to be equal, we're going to cancel this with this, and my dy by dx is equal 100y minus 12x x squared plus y squared, and let me see, oops, this 100x parentheses are here. 1 second. These parentheses are here. Okay, so it is going to be 12y. Let me rewrite. First I'm going to put this negative 100x because I'm going to do some changes. And then plus 12y times x squared plus y squared. Okay, so from here, what am I going to do? I can take 4 out of parentheses on the in numerator and denominator. Take 4 out of parentheses, and I will have 25y minus 12x minus 3x x squared plus y squared. And here we have, if I'm taking 4 out, negative 25x plus 12y, again, see, forgetting to divide, plus 3y, x squared plus y squared. Why it's 3y instead of 12? Because when I'm taking 4 out, there will be left 3, right? Okay, and that's it. Explicit derivative is equal this whole expression. So dy by dx is equal 4 is gone, and it's equal 25y minus 3x x squared plus y squared, and negative 25x plus 3y times x squared plus y squared. Now, we do not dare to cancel x squared plus y squared here. Why? Because this is the entire term is 3x x squared plus y squared and 3y x squared plus y squared, and on the top of that they are attached with tied up with addition and subtraction here, And when term is tied up with addition or subtraction, we cannot pull apart and cancel. So it's going to stay like that, which means, since remember, if you haven't forgotten, because it's such a long, we need to find the slope at the point 3, 1, right? Which means we are going to plug 3 as an x and 1, let me write down, at the point 3 and 1. So we are going to, because we need to find the slope, right? At this point, 3, 1, the slope. So therefore, it's going to be dy by dx is equal 25 times 1, right? This is your x, this is your y, minus 3 times 3, 3 squared plus 1 squared. Here in denominator, it's going to be negative 25 times 3 plus 3 times, well, multiplied by 1, multiply 3 squared plus 1 squared. Okay, this is equal 25 minus 90. Yes, what do we have here? 3 squared is 9 plus 1 squared is 1, 10. 3 times 3 is 9, 9 times 10 is 90. Similar way, we get negative 75 plus 30, and the result is going to be negative 65 over negative 45. And we reduce by 5, and the answer going to be 13 over 9. All right? There we go. So the slope at this point is going to be 13 over 9. Lastly, let me show you how to find the second derivative implicitly. So we have x squared plus y squared equal 25. That's a circle, obviously, with center at 0, 0, and radius is 5, because we have here 25. So we need to find second derivative. Okay? So 2x, let's start taking derivative dy by dx first. Yes? Okay, it's going to be derivative of x squared. It's going to be 2x, right? Because we take derivative in respect to x. And then derivative of y squared, it's going to be chain rule to y. And then dy by dx, which is going to be equal 0. From here, 2y dy by dx is equal negative 2x. And dy by dx is equal negative 2x divided by 2y. Yes, because here we have multiplication between them. So I am dividing by 2y both sides. And this is, we are getting first derivative, negative x over y. Now let's take second derivative. All right. So remember the formula for second derivative, x over y derivative is equal x prime y minus y prime x, and divided by whatever we have in denominator squared. Yes? All right. So we have negative x over y prime, right? And since we take in respect, I can, let me make it, write down this format so it would be better. So d of dx, negative x over y. Now, why I don't put a square here? Because negative x over y, it's already first derivative, yes? It's a first derivative, so second derivative, this d squared y over dx squared, it's going, if I have to take, it's a derivative of first derivative, then I will, that means I'm taking second derivative, which means second time I'm taking derivative. Okay? So this is going to be equal. Derivative of this negative, I will leave in front of fraction, yeah? We are not going to touch it. So derivative of x is going to be 1 multiplied by y. Next, minus x stay, and we're going to take derivative of y, which is going to be dy by dx, yes? And divided by y squared. Quotient rule. Now, next, I'm going to simplify. It's going to be y minus x times dy by dx. Let's see, how much is my dy by dx? Here it is. Look at that. Is equal negative x to y. So I'm plugging here, getting rid of this dy by dx. Instead of dy by dx, I'm going to plug negative x over y. See that? Okay. So remember, when you take second derivative implicitly, so definitely this dy by dx, you want to replace from the result of previous the differentiation, okay? And divided by y squared. Okay, so this is going to be equal negative. We get y plus x squared over y divided by y squared. And that is going to be equal, bringing to common denominator, y, it's going to be y squared plus x squared, yes, dividing by y squared, right? And if I divide, it's going to be y squared negative y squared plus x squared divided by y over y divided by y squared. That's going to be equal y squared plus x squared. And I'm flipping. Instead of y squared comes to denominator, right? And the result is going to be negative y squared plus x squared over y cubed. And this is going to be our second derivative, the answer for second derivative. Now, since, let me see, what do we have? Y squared plus x squared. Look, if we look at the very beginning, here it is. we have x squared plus y squared is equal 25, right? Our original equation. And I have here at the very end y squared plus x squared, which is going to be 25. So I can write down that it is equal negative 25 over y cubed. And that will be the answer. Did you understand what just happened? See, we have y squared. Let me take this color. You see we have here y squared plus x squared. So if when I'm looking at the original problem, here it is, x squared, y squared, or x squared plus y squared is equal 25. I just replaced y squared plus x squared with 25. And I got second derivative, d squared y over dx squared is equal negative 25 over y cubed. Okay? Okie dokie. Hopefully this helped. You understood. If not, obviously you can type questions in your comments. All right. See you next video.